So good morning, everyone. We'll just wait just a few more seconds for people to join the call. Okay, well, good morning, good afternoon, good evening, wherever you're joining us from. This is the third in our January series of webinars, and I'm pleased to say that the focus of today's discussion is to invite Dr. Chris Malins to talk to us about the role of alternative fuels in aviation, based on a report that he prepared for AAF late last year. I say it's the last in the series. It's been a series of 3 events that has been looking at alternative fuels and ways of propulsion for the aviation sector. As a mini recap, we started with the Tyndall Centre at the University of Manchester talking to us about the potential for ammonia, and then last week we had Professor Piers Forster from the University of Leeds and Dr. Alexandru Rapp, both from the Priestley Centre at Leeds, talking to us about the non-CO2 impacts of hydrogen use. And today's event brings the series to an end, and we haven't spoken much about the role of alternative fuels, or so-called sustainable aviation fuels, and that's today's focus. So I'm to give you a quick overview of what to expect. We have an hour. If you have questions at any point in the webinar, please type them in the Q&A. We will be recording today's event so that everyone can watch the event again, or people that haven't been able to attend this session can catch up later. But don't wait for the Q&A session. Please put your questions in the Q&A as they occur to you, and I will put them to Chris later in the event. So I'm going to shortly conclude my sort of welcome and introductory remarks. We then will go to Chris's presentation. I will then invite our Policy Director, Kate Hewitt, to say a few brief words about AAF's takeaway messages, and then we'll go into a Q&A session for the remainder of the webinar, and then I'll briefly close out at the end. So I'm going to introduce Chris. Chris is someone that we have worked with over a long period of time in different sort of forums and in contexts. But Chris is we turn to Chris because he's an alternative fuels policy expert. He runs the micro consultancy Cerulogy. Cerulogy has worked for NGOs, for government, for business on various issues relating to climate change and sustainability. But Chris has a particular interest in aviation fuels, as at one of the NGOs that participates in ICAO's work program. We nominate experts to the ICAO process, and that NGO group has previously nominated Chris to various ICAO working groups on the subject of alternative fuels. Previous to that, he has been the fuels lead at the International Council for Clean Transportation, and he's also been the comms lead for the UK Renewable Fuels Agency. And I should say that Chris holds a PhD in applied maths from the University of Sheffield. So I'm going to stop sharing my screen now, Chris. Over to you for the presentation.
Thanks very much, Tim. Bear with me one moment. Okay, hopefully everyone's seeing that okay. So thanks everyone for joining. I gather that we have an international audience, which is always gratifying. So thank you if you've joined either alarmingly early in the morning or late in the evening. We appreciate having the chance to talk to you. I'm going to be talking briefly about this report in three parts with an executive summary that I produced for AEF, as Tim said, at the end of last year. So you can go and read that in all its detail on the AEF website. The questions that I sort of looked into in this report relate to this question, relate to the way that we think about whether alternative fuels, or whether fuels used in aviation are alternative, whether they should count as sustainable, how we determine that they are low carbon. And as I imagine everyone watching this is perfectly well aware, aviation is a high climate impact activity. The climate impact of aviation is growing, whereas many other sectors are reducing their emissions. So there is an obvious need to work to reduce the climate impact of aviation. And for some years, the industry has certainly been claiming that it is going to start aggressively switching to novel fuels in order to reduce its net CO2 emissions. So that covers biofuels, so fuels produced from biomass. And more recently, there's been more and more focus on the idea of e-fuels, fuels synthesized from electrolytic hydrogen. And also, perhaps as a smaller potential pool, we have what is sometimes referred to as recycled carbon fuels. So that would be fuels developed through reclaiming the energy in waste fossil resources. So examples include people like LanzaTech looking to utilize the carbon monoxide in the off gas from steel mills, technologies to produce or reclaim energy from tires and waste plastics, this sort of thing. And the premise is, of course, that if these novel fuels have a low net life cycle greenhouse gas emissions, that's going to reduce aviation's climate impact. And relatedly, we assume or we hope that if they are produced sustainably, although I'm going to talk a little bit about what sustainably means, then we'll try not to incidentally cause other environmental problems. Certainly, in the case of biofuels, you could see lots of analyses that suggest that there's at least some environmental burden shifting, with some of the climate benefit being offset with other issues, in particular related to the agricultural sector. But as I say, alternative fuels are pretty fundamental to a lot of the net zero trajectories for aviation that industry and governments have proposed. I have an example here from a report called Waypoint 2050 by the Air Transport Action Group. You can see the big green wedge is sustainable aviation fuel. So in some of these industry roadmaps, really the real bulk of the heavy lifting to get aviation to net zero is assumed to be done with fuel switching. And this implies going to almost 100% alternative fuel by 2050. I will note, though, that there are other views. The UK, for example, in the Jet Zero strategy, looks at a somewhat more modest role for sustainable aviation fuels. It's a different shade of green, sort of a blue-green. Here, so 17% in the Jet Zero strategy instead of 71% in Waypoint 2050. But even at the 17% level, this is a really ambitious and aggressive bit of industrial deployment. So developing this capacity to produce these quantities of fuel is a challenge, even for these more moderate scenarios. The first part of my report discusses some of the issues around life cycle analysis and actually some of the challenges in correctly characterizing the net climate impact of switching to these alternative fuels. And I think it's always worth restating. I think we all recognise this if we think about it, but it's worth pointing out a greenhouse gas intensity of a fuel, as we talk about it in alternative fuel policy, is not a physical property. The carbon content of a fuel is a physical property, and to the first order, the carbon content of a biofuel or an e-fuel or a fossil jet fuel it is essentially the same, more or less the same. But when we talk about GHG intensity, we're talking about this idea of a life cycle greenhouse gas emission estimate. And this is generally going to be expressed in, well, depending on which side of the Atlantic you're on. In Europe, we talk about grams of carbon dioxide equivalent emissions per megajoule of fuel consumed. The carbon in the fuel, when you burn it, releases about 73 grams per megajoule. In the case of biofuels or e-fuels, we assume that that is offset by capturing that carbon as part of the production process, either through plant growth or literally through carbon capture. So when we look at life cycle analysis for alternative fuels, we're really focusing on the other emissions that occur through or that are associated with the production of those fuels. It's also worth noting, and I think sometimes the discourse forgets this a little bit, that while life cycle analysis is clearly a technical discipline, it is not an exact science. And what I mean by this is that the results of life cycle analysis are affected, sometimes quite profoundly, by methodological choices that are made, which are to some extent subjective. And those choices can be made a little bit more objective if we can clearly identify the question that needs to be answered. And questions that might seem similar on face value could actually lead to quite different answers. So I have two questions that I've put on the slide. Question A, what is the sum of the emissions associated with each of the processes that is required to produce a megajoule of a given alternative aviation fuel? Question 2, what is the net reduction in global greenhouse gas emissions that is achieved when policy mandates the consumption of an additional megajoule of alternative aviation fuel? And the first of these is what we would refer to as an attributional question. It's about attributing the emissions that occur through the life cycle to one of the, or to the product that comes out at the end. Whereas the second question is what I would refer to as a consequential question. So this question is about looking at the consequences of what you do. And what we tend to find is that the attributional question is the one which is normally being answered in regulatory life cycle analysis. So if you look at the Renewable Transport Fuel Obligation or the Renewable Energy Directive, or certainly parts of the ICAO CORSIA rules for life cycle analysis, and I'll talk about that idea of parts in a little bit. We have things that are framed in attributional terms. So whereas in a sense, the question that we would really like to answer, if we're talking about impact analysis of an alternative fuel policy or understanding whether we're really achieving what we want with alternative fuel policy, would be the second, more consequential question. But that can be a harder thing to approach. And therefore, we tend to fall back on the question which is a little bit more analytically well-defined. And this can be problematic because an attributional LCA approach can lead to results that are misleading in terms of net changes. So first off, attributional approaches can fail to capture overall changes in the system. I can give a very simple example of this, maybe thinking about the road sector. If you think about importing ethanol from Brazil to use in the road transport sector in the UK, you could ask, well, does that mean that there is more ethanol being produced in Brazil, or does that mean that there's less ethanol being used in Brazil? So actually, how much have you changed total fossil fuel use by moving that resource around? And the answer is that in an attributional framework, you simply don't know. You haven't attempted to answer that question. So you don't have a clear answer to that question. You have to do some additional work, look at the respective policy frameworks and economic frameworks in the two countries, and think about whether this sort of shuffling is possible or likely. Certainly, sort of relatedly, attributional LCA generically fails to capture what gets referred to as indirect effects. So we'll come back to this in a couple of slides. I won't start explaining indirect effects right now. There's also a question or an issue that occurs in any sort of part regulated market. So what I mean by part regulated in the case of biofuels would be that the only some subset of the agricultural sector, which is supplying feedstock for biofuel production, is subject to these life cycle analysis rules. The rest of the agricultural sector is exposed to a much lower carbon price than tends to be implicit in alternative fuel policy. So attributionality allows a sort of cherry picking. We especially with global supply chains and with rules that allow mass balancing through those supply chains, it's very simple to take the bits of the agricultural system that perform best in GHG terms and sort of assign those to our alternative fuels, and allow the less well-performing bits of the system to be allocated, as it were, to products where nobody is looking at the life cycle emissions. And a simple example of this would be the direct land use change restrictions that we have in the Renewable Transport Fuel Obligation, in the Renewable Energy Directive, that we will have if we have a UK SAF mandate. And that is because if I have two plantations, imagine I have two soy plantations in Brazil. One of them was planted at the expense of forest. One of them was not. I can simply choose to allocate the material from the farm that's been there for 50 years into the biofuel industry, allocate the material on the farm that has replaced the forest into the food industry. And it limits the effectiveness of those direct land use change restrictions in actually preventing land use change emissions. And this gets to this question of indirect land use change, which I'm going to come back to in a second. There's also a question in attributional LCA that has been raised by some sort of commentators and academics about being based on a carbon accounting. You could call it a shortcut, as some people refer to it as an error. This idea that is present in the IPCC greenhouse gas guidelines for the industrial sectors, and that has been adopted in biofuel policy, that we treat the combustion of biomass as delivering zero emissions in the inventory, in the life cycle analysis. And this is predicated in the inventories on the idea that those emissions are being captured elsewhere in the land use change and forestry inventory. But it's really not clear. Number one, it's not clear that that's always actually being well captured, and certainly those land use change, land use and forestry emissions might not be subject to the same carbon price. So you can have a sort of a shuffling, moving carbon around so that you don't really have to pay a cost on the carbon that gets emitted from land use change, and then you claim a benefit when biomass is used in a fuel application. And as I said, for all of this, attributional LCA dominates in regulatory contexts, although we do have some examples of what I might call hybrid LCA, so including some consequential considerations. And the reason that the attributional LCA dominates is, I think, partly that it's simply easier to define those requirements. It's also true that an economic operator has some control over the actors in their supply chain. So it does make sense to hold an economic operator accountable for things that they have some more control over, and maybe say, okay, we have to deal with these other things in another way, but that logic only goes so far. If you follow that logic to supporting technologies that maybe make things worse rather than better, we've had a long discussion over the last decade or so about whether, for example, palm oil biodiesel has in the net been making the emission situation worse rather than better. Obviously, if you're getting the wrong outcome, then simplification and giving people agency doesn't justify that wrong outcome. But consequential LCA is very difficult. It is subject to systemic uncertainty because if you're going to look at the consequences of something, you need to have some sort of model of causation. That can be very complicated to do, and it can be hard to make those models accountable. So I'm going to give a few quick examples of some indirect effects. In the case of biofuels, the effect which has been very well discussed and extensively analysed over the last 15, 20 years is indirect land use change. And this is a simple idea underneath it all. We know that when we increase feedstock demand for the biofuel industry, that material has to come from somewhere. Essentially, it either means that we have to produce more material on land that we already farm, or we have to expand the area that we farm. Or that we have to make use of residues or waste that are currently going unutilized. So you get into a sort of a somewhat complicated analytical question about what that balance is between whether you expect the system to increase productivity, whether you expect new land to be converted, and then what the carbon consequences of losing biomass and soil carbon on that newly farmed land are. And there's been a lot of analysis, for example, through Corsia, by the European Union and European Commission, by US governmental agencies, and by various academics that get into this. And there's certainly evidence that in some cases, indirect land use change means that a given biofuel system might be making net carbon dioxide emissions higher rather than lower. In the case of e-fuels, the indirect emission that we have to try to manage for is the risk that as we nominally take renewable energy capacity to produce hydrogen, that could mean that you either bring or keep more fossil power capacity online in order to supply other users. And if that isn't done properly, if you don't have genuinely additional renewable power coming online to feed your hydrogen industry, your e-fuels industry, then you're liable to make things worse rather than better. The e-fuel production system is only going to be roughly 50% energy efficient, so you don't need to have a very high carbon intensity for the electricity production going into that process before the sort of the real net carbon impact is going to be problematic. So managing whether renewables are being additionally generated for e-fuels becomes very important. And in the case of recycled carbon fuels, you have to think about alternative dispositions. An example would be waste plastic. It's clear that plastic going into landfill is not an environmentally desirable outcome. But also, you know, one of the criticisms, if you like, of plastic waste is that it's very persistent in the environment. This is material that will remain in the environment for thousands of years, but that does mean that the carbon would be sequestered. So when we talk about taking a resource like plastic waste and treating it in a sense as free carbon, as carbon that we can utilize and emit, without counting that as an additional emission, I think that you need to be quite thoughtful about that. And there's a real question about the way that climate policy interacts with waste policy, and whether there's a little bit of a risk that with some of these recycled carbon fuels that we're giving a climate policy value signal to something that really is actually only delivering a waste policy benefit, i.e. we're sort of paying a carbon price in order to reduce the amount of plastic in landfill, but without delivering as much climate benefits. So that's challenging. And through all of this, I think the message in the report is just to understand that LCA is limited. and that while alternative aviation fuel policies are going to use LCA tools, that's standard now, that's part of the policy economy, these need to be complemented both by regulations. So we've got things like the high islet risk idea, limits on the use of palm oil as a biofuel feedstock, for example. In the case of e-fuels, setting clear requirements on additional renewables, and setting feedstock eligibility limits. And to recognize that we have consequential tools, you can bring those in to create hybrid LCA systems. So, for example, Corsia has numbers for indirect land use change as part of the assessment of aviation fuels, but you can also use those tools as part of impact analysis, use it to identify issues that require other regulatory answers. So just take note, business will want to take its LCA number and quote it as if it's true. And let's just understand that all LCA results are a little bit subjective. They're subject to the methodology, and they're worth digging into a bit more. So part 2 of the report dug in a little bit more to some of these waste issues. The UK government certainly sees waste to fuel pathways as preferred for aviation fuel, including biogenic wastes. And on the waste policy side, the UK government also has various policies to reduce or eliminate waste generation, eliminate avoidable plastic waste by 2042, eliminate food waste from landfill by 2030. And UK policy also it does follow a waste hierarchy, where at the moment energy recovery is placed in the hierarchy below reuse, recycling, composting, or anaerobic digestion. So there's a little bit of a policy tension between the sort of the waste policy imperative that puts energy recovery a little bit lower on the list, and this increasing interest in waste to fuel as a way to produce alternative aviation fuels and to contribute to waste management. There's important questions when we sort of talk perhaps sometimes a little bit lazily about waste, about how wasted some materials actually are. So various things that get described as waste sometimes actually are used, and sometimes used with relatively high value. So an example is rendered animal fats, the sort of animal fats recovered from animal carcasses after the meat and fat for human consumption has been extracted. And these are all used at the moment in pet food applications, oleochemicals, road transport fuel applications, of course. And displacing any of those resources or similar resources out of applications that they're already in is going to drive feedstock switching. So you take the animal fats away and you have to use something else. So a life cycle analysis framework that treats that as a free resource is missing something really quite important there. And most life cycle analyses don't directly consider this. But it should be noted that the UK in the Renewable Transport Fuel Obligation actually has really quite a strong system for identifying whether things should be treated as wastes or not. So the UK is quite somewhat ahead actually of the rest of the world in being fairly strict in whether to incentivize materials as waste. But it's still an important area to keep an eye on, and it's always worth noting that new uses for waste are being developed all the time. So alternative aviation fuels may find themselves in competition with other uses, and we need a framework to think about which uses are better than others. That means getting into counterfactuals and future counterfactuals. You can think about using life cycle analysis tools to assess the implications of the change of disposition of waste, so whether it goes from an existing use, even actually if it is being disposed, sometimes you can identify an additional benefit. For example, taking biogenic material out of landfill can reduce methane formation, so you actually get an additional climate advantage in those cases. But looking forward, fuel production is going to compete for waste feedstock with other types of energy recovery, potentially with recycling, as I said, potentially with other sort of new ideas, maybe chemical recycling, to the extent that and that becomes a more of a focus area. And in some cases, fuel production might avoid feedstock being sent to landfill. And the RTFO has sort of a standard counterfactual set on the use of municipal waste, which is, again, it's a sort of a hybrid system. We have a little bit of consequential thinking here, which I think is positive. It takes a low efficiency incineration for electricity as the standard counterfactual on municipal waste, and that affects the way that the life cycle analysis is going to be rated. Across all of this, converting waste to fuel is going to be seen often as delivering both a climate and waste management benefit. But we do have to recognize that actually sometimes only one of these benefits can be achieved at the time. If you're reducing landfilling, then that means that you're actually not delivering much climate benefit because you're not storing that carbon in landfill. So it's important just to be realistic about how that waste management benefit and that climate change benefit that you're looking for can be combined. Now, as I said, there's a risk that you set a carbon price on a waste management outcome. Now, part 3 of my report talked a little bit just about the scale of the challenge in terms of industrial development that is represented by trying to meet some of these alternative fuel targets going up to 2030 or 2050. Oh, that's my phone telling me that I've been talking too long. Forgot that was going to ring. So I'll try and wrap up a little bit quickly so we have time for questions. So the EU has a 70% target for 2050. The UK is currently talking about 50%. And as I said, there's industrial scenarios or industry scenarios published that suggest nearly 100% or 100% replacement. At the moment, the only fuel commercially available is heifer, produced from animal fats and vegetable oils. And there's a lot of sustainability issues there because heifer is using high-value vegetable oil resources. We have indirect land use change issues, food market competition issues. Even if you go to these sort of secondary oils like rendered animal fats, in general, that material is already being well used. And no one is really claiming that heifer is scalable to 2050 targets. Some people will say that you should invest in heifer now in order to sort of get a bit of a head start. I would say the opposite. You have scalable solutions that need commercialization and investment. The more resource that you put into heifer in the short term, the more you delay doing those things that you actually need to do more. And the UK has indeed proposed to quite strictly limit heifer under a UK SAF mandate, which I think is the correct choice. The Refuel EU policy that the European Union has introduced does not really provide that same market protection. So the impact analysis on Refuel EU suggests that they expect about half and half between heifer technologies and biomass to liquids technologies, or by, I can't remember the time frame I'm talking about now, maybe 2035, maybe 2030. I don't see that as credible. I think that if you give those relatively even signals that you are going to get more heifer than you intend to. But whichever technology pathway you're following, combining the 2050 EU and UK targets, it implies about 37 million tonnes oil equivalent of SAF demand. That's hundreds of plants that need to be operational, billions of euros, billions of pounds of investment that need to be made, something of the order of, depending on the balance between biomass, biofuels and e-fuels, something like 100 million tonnes a year of biomass, 120 gigawatts of electricity demand. Delivering all of that requires certainty, investment certainty, but alternative fuels are significantly more costly to produce than fossil fuel. So this is an industry that will be completely policy dependent. It's going to have high implied carbon abatement cost. And the cost of electricity makes the power to liquids value proposition, in my view, particularly challenging. And then we have a policy framework, the sort of the mandate framework is actually designed to deliver value uncertainty, which is a sort of another way of saying that it's designed to allow things to be done as cheaply as possible for the fuel consumer and the taxpayer. So a mandate is sort of designed to home in on the lowest cost solutions, but as a technology developer, that's not necessarily helpful. You want value certainty. Instead, we have a policy that guarantees that when someone undercuts you, your certificate value will start to go down and challenge your business model. And this lack of a clear value proposition has undermined advanced alternative fuel mandates in the past. And for this reason, the UK is looking at developing proposals for a revenue certainty mechanism to couple with a UK SAF mandate. And we also have defined penalties and buyout prices in policy that help to clarify that situation. But certainly, I think that it's worth continuously revisiting whether we actually have an industrial development policy that works. On a slightly separate issue, it is worth talking about, for example, when we're talking about that 120 gigawatts of electricity, it's worth just taking a moment to think about whether it's going to make sense to use all of that electricity resource in aviation fuel. There's a lot of other ways that you could use that electricity, and new industrial electricity applications are being commercialized all the time. And synthetic jet fuel, according to the Committee on Climate Change in this case, it's not going to deliver the most carbon bang for your unit of electricity in general. So there is a real question as we talk about devoting these very large resources of biomass or of electricity to keeping planes flying and allowing them to be counted as net zero, whether that is really going to be the best use of our ability to put more renewable electricity capacity in the ground. But we should note there's also a couple of co-benefits that we can have from alternative aviation fuels. They certainly burn cleaner than fossil fuels, and there is a potential for reducing non-CO2 emissions when we use these cleaner fuels. So to conclude, fully characterizing the GHG impacts of these new fuels is difficult. Resolving the non-CO2 impacts or thinking about non-CO2 impacts will be increasingly important. I've been talking about really carbon dioxide, methane emissions, but a large part of the climate impact of aviation is non-CO2, and that's only at best partially dealt with by using alternative fuels. Commercial deployment of alternative fuels will require strong value signals. You have to do more than just set a big target. And all of this, and you can read this in the Part 3 report in more detail, will really take a lot of capital and commitment, and it will increase the cost of flying. And finally, just to sort of leave you hanging on a bombshell, there's a question that I think is going to come up more and more about whether an alternative fuel model is better than a model that says, let's just use fossil fuels and capture carbon to offset that, because you could sort of make a case which I haven't got into in these reports, but which I think will be something that gets into the discussion again and again. You could say, right, why are we capturing carbon to make alternative fuels? We could just capture that carbon and stick it underground, and that might be a less costly process. I was going to give you a closing thought about sustainable aviation fuel as a term, but I'm running late, so we'll save that. So I'll say thank you very much. Sorry for overrunning my slot slightly, and I'll have a look and see what our questions are.
Thanks very much, Chris. Not at all. I mean, thanks for taking the time to run us through what's a really comprehensive, I was going to say, set of reports. As you alluded to, it's 3 separate volumes and a summary report. So Florence has put in the chat for all of you to see the link where you can find those reports. And so do click on that after the webinar. We'll also include it in the post-webinar materials. Before we get to questions, Chris, and there's a queue of questions already come in. So in order to get through them, let's go for sort of brief answers and let's see how that leads us with time, because I think it will generate more. But before we go to you for questions, let's invite Kate Hewitt, who is our AES Policy Director, to say a few words about AEF's takeaway messages from the report. Kate.
Thanks very much. Yeah, and thanks to Chris for the report. I would like to think that the whole process of reading and digesting it has expanded my brain a little bit, but maybe that's wishful thinking. We at AEF, really kind of drawing on Chris's work, wanted to set out our own current thinking and policy recommendations around this issue. We did that in our own short report that we put out at the end of last year called Sustainable Aviation Fuels, Hope or Hype. I'm going to take really just a couple of minutes to run through our top lines from that report, some of which Chris has talked about already. So the first was the one that you ran out of time for, Chris, which was just that the term sustainable aviation fuel to describe all non-kerosene liquid fuels for aviation isn't helpful. I think some of us feel like we've let the horse bolt on that one a little bit, but in fact, the sustainability of alternative fuels should be assessed rather than assumed. Secondly, we need a better quality conversation about how alternative fuels work as a tool of climate mitigation, based on the understanding that they deliver no CO2 reduction at the tailpipe. At the moment, I think we feel there's a lot of misleading statements made in the media and sometimes from the industry along the lines of this fuel can reduce aviation emissions by 70% or 80%. And that's just wrong in my view. And that increases the risk really of goal setting at a political level. It isn't based on the right information. Then there's this whole question of life cycle analysis. Chris has said very clearly the discipline of life cycle analysis is deeply entrenched as a process for appraising fuel sustainability. Nevertheless, as he's shown us, the LCA score of a fuel can vary hugely depending on what assumptions you make, and in some cases can lead to perverse outcomes whereby a fuel is purported to reduce emissions by greater than 100%, even in the absence of any carbon capture component. AEF's view is that there's some merit in what Chris describes in his report as the additional carbon framing in appraising which alternative fuels deliver additional atmospheric CO2 in their production and use, rather than those that simply make I guess opportunistic use of waste carbon that would otherwise have other uses or might degrade more slowly. There's a need more broadly for greater transparency about how different systems of carbon accounting align to ensure that no emissions are lost and no savings are double counted. There's some evidence that Chris has highlighted in the report that alternative fuels may generate lower non-CO2 impacts than kerosene. Our view is that until we have targets in place for tackling the non-CO2 impacts from kerosene, then we need to avoid creating policy incentives for alternative fuels based on sort of any theoretical or hoped for non-CO2 benefits. And then finally, I think our view is that if we restrict our focus, our policy focus, as I think AEF believes we should, to fuels that result in additional carbon removal from the atmosphere, that would rule out waste-based fuel. And in that context, actually the role of alternative hydrocarbons or SAFs in aviation decarbonisation starts to look very limited. And on that note, I will pass back to Tim to moderate all the questions that have been coming in.
Thanks very much, Kate. So one of the things that we sort of alluded to in our takeaway messages, Chris, that you sort of perhaps didn't have time to explore in the presentation this morning, was that about additional carbon. I mean, do you have additional thoughts on top of Kate's?
Yeah, so for those who aren't necessarily familiar with the idea of the additional carbon framing, this is a sort of a way of thinking about alternative fuels and life cycle analysis, which is proposed, which is that that you shouldn't treat biogenic emissions as zero in your carbon accounting, because doing so means that you're treating land effectively as a free resource, and you ignore the opportunity costs. So the idea is that if you're going to be able to make a claim that a biomass-based fuel is actually going to have lower net carbon emissions, then you have to identify in the system where you are either bringing additional carbon down from the atmosphere, or where you're reducing a flow of carbon dioxide up to the atmosphere. So for example, if I have a field of corn, which has been, in a sort of a corn rotation for the last 50 years, and I start using that corn to make ethanol, and maybe using the ethanol through alcohol to jet to make jet fuel, then there's no change in the carbon flow to that cornfield. So we're not getting any additional carbon dioxide down from the atmosphere. So I don't have a basis to make a net zero claim. You have to look a little bit further. So I think of this as sort of doing indirect land use change analysis, but starting at the other end. Indirect land use change analysis, it's sort of a way of saying, well, we're going to treat biogenic emissions as zero, but we're going to go looking to see whether actually there's some exceptions to that, and we should add some opportunity cost emissions. Additional carbon framing says, no, we're going to be a bit more active. We're not going to allow you to make a claim about low impact unless you can actually tell us where your additional carbon is coming from. I think it's a very good discipline, if nothing else, sort of for impact analysis and for government, when you're thinking about a new type of fuel pathway or existing types of fuel pathways. If you can't identify the additional carbon, that's probably a bad sign. And I think to some extent, this, if I can pre-answer, like Doug had asked, is given uncertainty in LCA is a mandate for fuels even the right approach? Well, what I would say is that I think there are fuel pathways that you can say with some confidence probably are delivering net carbon benefit. So the challenge is to limit your fuel mandate to those where you have a good sense that you are delivering a benefit, and to make sure those are the ones which are getting supported. And of course, traditionally, that hasn't always been done entirely successfully if we look at the road transport sector.
Thanks so much, Chris, and thanks for getting us into the Q&A that the audience has submitted. So let's pick up on that. So there's a question from Aoife O'Leary from Opportunity Green, and Aoife asks, with all the caveats on life cycle accounting, what are the policy implications? She wonders if one of the outcomes is that we should double down on the easier accounting, i.e. the bad that comes out of the aircraft tailpipe already, and properly price them.
I mean, to some extent, this isn't really a question for me. Certainly pricing the CO2 impact of aviation would be beneficial in climate terms. I don't think that should be enormously controversial in and of itself. It's clearly a somewhat divisive topic. It's not something I would personally have any objection to as a measure that could be taken.
Okay. So Bernard van Dijk asks, is there any consideration in these reports when all ground transportation electrifies of the biofuel which we currently use in ground transportation, E10, about the potential for that to be transferred to aviation without changing land use? And I think that's the key point. To what extent can we sort of divert supply?
I think there's a little bit of a sort of a misconception. I think that the question treats agriculture as a static system, and that isn't really true. We have a growing population, we have a growing economy, demand for agricultural produce increases steadily. So if we start to wean off of road transport biofuels as road transport electrifies, and by the way, there's a whole world of vehicles out there, so it's going to be quite a while before we run out of road vehicles that you could put road biofuels into. But even if we're weaning off of those, there's still an opportunity cost of taking that resource, which is currently going into ethanol or ethanol or biodiesel for road transport, and shifting it over to aviation fuel, because you could have just let that go back to the food market and still reduce demand for additional agricultural expansion. I've even heard people make sort of the opposite argument, I think, in a sense, which is to say, well, we might as well expand biofuels now because we're going to need the food eventually anyway. So all we're doing is bringing the land use change forward a bit. And then in due course, you release the land back from the biofuel sector to the food sector. So I do think if you try to think about the agricultural system as static, you end up drawing conclusions that don't quite stand up. I mean, certainly as demand for road transport biofuels reduces, that will give a little bit more flexibility back into the system, but I don't think you can usefully look at it as this sort of one-to-one thing and claim that you can create this new market without having any impact on net carbon emissions. It is just not quite that simple.
Yeah. Okay. Anna Stratton from Climate Works Foundation asks whether you could provide more details on why the UK regulation is ahead in terms of identifying whether something is a waste material.
I mean, I think in short, the Department for Transport has been quite attentive to this for some years. They were arguably sort of ahead of the curve with what's been done in Europe in looking at displacement effects of using waste. Back when I was at the Renewable Fuels Agency, I used to go to conferences to present work on displacement effects of using waste for biofuels. And DFT has remained quite firm on that. And I mean, you know, heaven forfend that I claim a Brexit benefit, but actually there is a bit of flexibility that goes with being out of the Renewable Energy Directive framework, which is maybe a little bit more prescriptive, which does mean that the Department for Transport is able to do an assessment on waste and residual materials on their merits. And I think that that's done quite well.
Thanks, Chris. There's a question from Finley Asher from Safe Landing. So Chris, you mentioned that the UK waste management hierarchy puts recycling and anaerobic digestion above energy recovery and fuel production uses. Would this not mean that all biogenic waste should be either composted or sent to an anaerobic digester rather than used to produce jet fuel? And Finley's understanding is this would apply to inedible farm waste, leaves and branches from trees, as well as food waste. So is there any biogenic waste that couldn't be used this way? And if not, does that rule out most aviation biofuel production?
Well, I think the first thing to just note about the waste hierarchy and the waste hierarchy idea is that there's always a sort of an accommodation there that says that if you have a greater environmental benefit from doing stuff that doesn't fully align with the waste hierarchy, then that can be acceptable. So the waste hierarchy isn't necessarily intended to be sort of understood as totally set in stone. But I mean, I think that the basic observation it is somewhat correct. You know, the way that we currently frame the hierarchy, aviation fuel use does fall a bit lower. So it sort of comes down to whether you're gonna, or you know, whether policy is sort of adjusting that hierarchy and therefore implicitly saying, well, we think that the benefits of using this material in this particular energy application are actually greater than producing more compost, for example, or you know, maybe some resources are rather more easily handled with a fuel production pathway than with an anaerobic digestion pathway. So there's various ways that you could sort of frame that decision not to follow the hierarchy really, really strictly. I'm not sure that that's been sort of stated with total clarity. So there's definitely, my view is that there is a tension in the way that the hierarchy interacts with the focus on aviation fuel.
So I think we have a very sort of similar question in many ways from Suzanne Becken, which is in the actually in the chat rather than Q&A, but it asked, given the chart you showed from the 6 carbon budget with the very low carbon reduction benefit per megawatt hour, sorry, for synthetic jet fuel, why is it that governments still develop policies in favour of SAF development rather than doubling down on phasing out thermal coal plants, for example? There is an opportunity cost of subsidies in some cases, which means that governments either don't understand the implications of supporting SAF, or there are some strategic political reasons for doing so.
I think that, I mean, I think part of it can be justified by saying that you have to be looking forwards. So there's a pathway to, you know, what one would argue is that there's a pathway to eliminate thermal coal, and that it takes time to develop other things. So you're looking beyond those initial priorities in terms of industrial development. I mean, I personally would argue that there's probably too much policy focus, in my view, on scaling up SAF production rapidly. I think that ought to be reframed a little bit as a technology development priority, because indeed it is a little bit counterintuitive in a world that uses quite a lot of coal in total. It does seem to me that there's a question mark about whether it makes sense to be thinking about doing a real large scale alternative fuel industry, e-fuel industry. There's always, or there always can be complications in terms, for example, of where renewable electricity is being generated, whether the resources that you are going to generate, which would be used to produce e-fuels, would actually be located in the right place to be able to displace thermal coal power generation. So there's some real questions like that. I do think maybe that there's a sort of a little bit of excitement about talking about aeroplanes sometimes, and I think that there is an apparent political desire to avoid getting into a conversation about aviation demand management, which I have always thought is a conversation that will have to happen in due course. You know, aviation is resource intensive activity in the context of the energy transition. I think you have to talk about these opportunity costs, etc., etc. So I think that there's some reasons for getting ahead of this that I'm a bit sympathetic to, maybe some that I'm less sympathetic to.
Well, I'm going to try and squeeze in 2 last questions. So James Beard from the European Climate Foundation says you talked, Chris, about the observable past present land use change and the policy goals for future waste reduction. But what about policy goals for future land use change? For example, the UNCBD sets goals for restoring 30% of natural habitats, which is a zero-sum alternative land use versus SAF feedstock production. So how is or should this be dealt with in SAF LCA?
Well, I think part of the answer is that this isn't necessarily a life cycle analysis question. You know, just as if we're talking about crop-based fuels, competition with food is a real thing, but isn't necessarily a life cycle analysis question. So competition with nature restoration is an important thing, but can't, I don't know that it's useful to sort of try to assign a carbon cost to species loss. You can produce sort of, I mentioned this earlier, you can produce metrics that weight different environmental impacts with different values. And as I say, if you go to one of those fuller metrics, what you tend to get is a reminder that agricultural production does generate air pollution, does result in water use, generates eutrophication, you know, tends to be associated with species loss. So there's all of these issues that go with using an agricultural resource. I mean, what can be done with SAF, and certainly for the sort of initial expansion phase, that there are resources out there on the biomass side which are genuinely underutilized. and there's generally sustainability issues with any sort of really large scale transfer of a biomass resource. But when we look at agricultural residues and to some extent, smaller volumes forestry residues, there are opportunities to increase harvesting that I think don't have to be environmentally problematic. But there's always a great deal of tension about whether you're willing to draw those eligibility criteria, I guess, on feedstock really, really tightly, so that you say, no, we're definitely only going to do the stuff that we think isn't going to have a negative impact, because there's always going to be pressure on the industrial side that says, well, this is really quite expensive enough already. We don't need restrictions that make it much more costly. And it is an investment challenge. When you go in for a resource that maybe costs a little bit more because it has better environmental performance, you really are reliant on government to maintain that standard. So this can be a sort of a challenging thing to do. But I certainly, we have an odd discussion with SAF, because on the one hand, the world produces hardly any of it at the moment, and on the other hand, we're talking about vast quantities really by 2050. So we have this imbalance of scale. I think for the next 10 years, you could draw your resource base quite narrowly and produce fuels in a way that you would then be able to demonstrate, hopefully, didn't have any negative environmental impact. And then you should sort of right size it. I think really we should be identifying how much fuel can be sustainably produced, and then do that to the extent that it makes economic sense, rather than, I think it is sort of dangerous when we say, well, we want to keep flying, so we're going to move the whole aviation fleet to alternative fuels, so we need whatever I mentioned 100 million tons of biomass, go globally even more. I think that does become a little bit risky, because it creates a lot of pressure to meet those targets, even if you start to notice some negative side effects.
I'm going to probably have to wrap up the Q&A there, but there is a very quick question from Doug Parr that I think perhaps might require a long answer, but I know there is a very short answer to it. But we talked about a lot of the problematic feedstocks, but if you were trying to design a good SAF policy, are there any sort of feedstock pathways that do make sense from a greenhouse gas point of view? You may not be able to answer that in a sentence, Chris, but if you can, that would be great.
Well, I can sort of, because I do think that it is, you start with the agricultural residues, forestry residues I just mentioned. So I think there is an opportunity to take material from municipal waste and wasted biomass. This is laid out in moderate detail in some work I did with the European Climate Foundation a few years ago that was called Wasted. So if you Google Chris Malins Wasted, you'll either find the report or some amusing pictures.
Chris, that is great. Thank you. Thank you so much. So a big thank you to you, not only for the presentation, but for the thorough answers to the Q&A. A reminder that a link to Chris's report is in the chat. Sorry that we haven't covered everything that was put into the chat. There's been some very helpful responses to questions. Finley, thank you for your sort of responses to other people's sort of observations and comments in the chat as well. To people that asked about slides, yes, as a follow-up to this, you will get both a recording of this webinar, but you'll also get a link to the slide deck as well, so you can see that, and of course that will have a link to the reports. I'm not going to wrap up on AEF's thinking, because I think that was covered very well by Kate earlier. So a thank you all for joining today, and for those that have joined other webinars in this series, thank you for participating in those events too. And I'm just going to end by thanking Chris once again for the presentation. I hope you enjoyed it and took away something from it, and look forward to seeing you and interacting with you all very shortly. Okay, thanks very much. Goodbye.